Okay, guys, final unit. All right, this one's a little bit different. This is all new. The first time that it was taught in high school has been this year, and so to be fair, I didn't feel like learning target questions would be appropriate, simply because I needed to see where everybody was going to struggle, if they were going to struggle as we went along. I need to see what I did well at teaching, what I didn't do well at teaching for this unit. So the last few days here are going to be play-along points. Think of it that way. You participate, you stay off your phone, you be a nice person, and you're going to get some easy points to end the trimester. Good news is I have been through this now with Physical Science B during second try, so I do know where some of the hiccups are going to be, but we may run into one or two. Just play along, participate, and hopefully you will find this interesting. I was hoping to be back for this part. Doctor says no. It's looking like I will be in the room during final exams at least. All right, so if that's been a concern, it may not even be a concern. I know Ms. Klein's doing a heck of a job, all right, but it is my goal to be in the classroom, and it looks like that probably can happen when you take final exams next week, all right, almost there. So this unit, it goes right along with the gravity, but now we're just thinking big picture. Okay, ultimately, explain what in the heck is happening in the universe, because if you hopefully pay any attention to the news, and I probably did not enough in high school either, at some point you will hopefully pay attention to the news, and maybe get off the mainstream stuff where you've got a bias one way or another, and do some smart research. You know, get some good objective sites that aren't tainted by either political party. Just look at some good objective stuff, make your own decisions. And that's why I wish I was here for this part, because I love getting different opinions. And so I know I'm not there, but don't feel like you're offending me if you don't believe in some of the stuff we talk about. You don't have to believe it. When we talk theories and laws, it's just this is what the science supports, but what if it's because we don't know of something else that exists? All right, when we talk about Big Bang Theory, and we'll talk about this a few different times, but I think most of us know from middle school even, that the idea is that everything was once in like the size of just a pinhead, even smaller than that. Extreme pressure buildup goes boom. Well, things are spreading out, and you would think, since it's a theory that gravity only pulls, okay, so those things, those chunks of matter that are flying outward after the big boom, they should be tugging on each other. So you would think that we would be expanding at a slower rate. Like we should be slowing down. When I first started teaching, back in the 50s, it's a joke, okay? But when I first started teaching, there was a theory called the Oscillating Universe. And that's the idea that, well, things are going to slow down and they're going to stop. And so let's just say Earth and Saturn, all right, so we're stopped out there. Well, we're going to start tugging on each other, and we're going to tug on the Andromeda Galaxy. And so then we would start to come back in, and the closer we got, well, the law of universal gravitation says we should go faster because gravity's pulling. And we should go faster and faster and faster and come back together. And then we would go boom again. So like an oscillating fan, things that go one way then back the other. That's what we thought the universe was going to do. Not so much. Okay, what's actually happening, and we'll talk about how we know this probably next class period, is we are going apart at a faster and faster rate. How is that even possible? Like, what would make us speed up? Why would we be getting away from the other galaxies and the other stars at a faster and faster rate? That doesn't make any sense. So is something pulling on us? I don't know, okay? Nobody really knows. There's theories out there. So people say, oh, it's dark matter, or oh, it's dark energy. Until we can find that dark matter or find that dark energy, it's just a theory. So, I hope you keep an open mind. Please, sorry, gagging over here. Please make sure you know I'm not trying to tell you that any of this should go against any philosophical, religious, whatever belief you have. I'm just giving you the science right now, and science is proved wrong every day. All right, so keep an open mind. That's all I ask. So our goal today, though, is just to distinguish, so write this down, between a scientific theory, and then a scientific law. Okay, a scientific theory and a scientific law. You kind of have to understand those, and I'll try to put it into other aspects, forgetting about space science a little bit to try to make this make sense. All right, so what I'm going to do, let's write down scientific theory first. So here, let's get our little chart. So evidence, interpretation, and you've already watched that video, that 7-minute clip. So hopefully you've got some ideas already. But I always feel like the distinction between these two is a little wishy-washy. But let's start with scientific theory. It'll say, if you Google it, a well-substantiated. I feel like substantiated is too complicated. So what I like to think of it as is a well-supported and defended explanation of an observed phenomenon. Okay, so it is a well-supported and defended explanation of an observed phenomenon. You can't think of a theory as how we use it every day, like in life. So, like, tell my kid to clean her room, and 9 times out of 10 it doesn't happen. All right, we've all done this. You know, you get bossed around, go clean up that. You know how it goes. And so, like, I could think, well, I have a theory as to why it didn't get done. She got sucked into The Office on Netflix. That's my theory. All right. And there may be some evidence to support that, but it's still not concrete enough. Like, I would have had to physically observe her watching Michael Scott on The Office to say for sure, yep, that's why the room didn't get cleaned. All right? So these theories, it can't be just you look out and say, grass is growing pretty fast. My theory is, or whatever. Okay, it's got to be a little bit more sciencey. But what a theory does, more than anything, it's the why. Why does something happen? Okay, we can use it to make predictions. So if we see something that's happening, so like my grass is growing like crazy now, my theory is, well, it's been humid, we've had some sunshine. That's my theory as to why the grass is growing so dang fast. All right, so we can use it to make predictions. Leave a little space because we're going to come back. A law, even if it doesn't have the word law in it, this is like the observed phenomenon, and it usually describes it. So it's a description of the observed phenomenon. And a lot of times, especially in this class, it uses math. It's hard to argue with numbers. Okay, so a lot of times it uses math. So this is the why to explain what is happening. Okay, this is what we see or hear or notice, that sort of thing. So here's an example. And I know evolution is a fairly controversial topic, and I don't ever dodge around it. I just want you to know you can believe whatever you want to believe, all right? But you just have to know what science thinks and why they think it. They could be full of crap, all right? But that's all I ask. So when we think about evolution, that is for the most part a law, the way that science would use it. When you see fossils change, okay, when we see that there's fossil evidence, so we can't really argue that bone structure has changed in different organisms. All right, so I'm not even talking people here. I know they sent a picture, or there was a picture in the video, but I don't even need to go there. All right, let's just talk about, I don't know, a change in the structure of a fish, right? We've got fishing folks in here. And so over time, fish structure has changed. But the why, the how, okay? If this is the law, it's happened. There's fossil evidence, it's happened. The theory behind it is the theory of natural selection. It's that survival of the fittest. If some fish, and it's usually a mutation, a genetic freak that says this fish all of a sudden maybe has a bigger dorsal fin, right, on its back, and it makes it better able to escape something that's trying to eat it. Well, that freak mutation made it better able to survive to generate more other freaky fish that can then escape predators. That's what science says is the reason behind evolution, at least one of them. But still a theory. Okay, still just a theory. Here's one. The law of universal gravity. You'll love it. You just took the test on it. Hold on, I gotta grab my formula sheet. You hear that flapping around? Earl just flew into the room. Charming. So here's the law of universal gravity. Okay. That predicts the force between objects, how fast things will fall, that sort of thing. But that relies on our theory of gravity. So the fact that gravity only pulls. Okay. This explains that. Kepler's laws. Okay, remember Kepler's laws. It's a whole 1 page, I lied, 2 pages back. So the law of ellipses, the law of equal areas, the law of harmonies. Math tries to explain these. Okay, math tries to explain them. Math doesn't explain that one, but in a way it does, because we know the speed of the orbits within the orbit is changing. But there's theories that we have to assume we know what the heck's going on with gravity to make this stuff true. Okay, so gravity would help support those laws. And here's another one. Maybe you hate this space stuff. Ohm's law. I guarantee you somebody in these classes is going to make a whole lot of money being an electrician. Remember the VIR triangle? That's a law. And last but not least, the one that we're going to spend most of our remaining days together on, I'm out of room, Big Bang Theory. It's a theory, guys. Okay, we think it's right, but it's a theory. Okay, it's trying to explain why are things moving apart. But what it can't necessarily explain now is why are they speeding up. So that's where we're probably going to discover something pretty shortly that explains that. So maybe Big Bang Theory will get thrown and flushed. Who knows? All right, so hopefully that just gets you an idea. Theory tries to explain the law. The law, here's what we see. Theory tries to explain it.